Let's analyze this equation. Y double prime minus y prime equals 2x plus 3. Clearly, this is a second order equation. It's linear, it has constant coefficients, and it's non-homogeneous because the right-hand side has a non-zero term. Now, as usual, we are going to first solve the associated homogeneous equation, which is y double prime minus y prime equals 0. The associated quadratic equation is lambda squared minus lambda equals 0, which can be solved by factoring lambda times lambda minus 1. So we obtain one solution, lambda 1 equals 0, and the other solution, lambda 2 equals 1. Therefore, the general solution of the homogeneous equation is given by y of x equals c1 e to the 0x, which is simply 1, plus c2 e to the x, where c1 and c2 are real numbers. Okay? Now, we have to find a particular solution. Of the non-homogeneous equation. According to what we studied, the right-hand side, since the right-hand side is a polynomial of degree 1, then I should look for a particular solution in the form of a complete polynomial of degree 1, which has the form ax plus b. Okay, so let's try this. In order to plug it in, I need to compute the derivatives. So the first derivative is a, and the second derivative is 0. So now, if I plug into the equation, I have y double prime, which is 0, minus y prime, which is a, equals 2x plus 3. So notice that already we face an impossible situation because the left-hand side is a polynomial of degree 1, while the okay, this is the right-hand side. Sorry, that's a polynomial of degree 1, and the left-hand side is a constant. So this cannot happen. Okay, basically I do not have an x term here, so these two polynomials can never be the same, which means this is not the correct form of a particular solution. So in this case, we need to multiply by x. So take this polynomial and multiply it by x, therefore obtaining ax squared plus bx as your particular solution. And now let's try with this. The first derivative is now 2ax plus b, and the second derivative is 2a. Now if I plug into the equation, I have y double prime, which is 2a, minus y prime, which is 2ax plus b, equals 2x plus 3. And I realize I will need to arrange terms, but we can already see that now we will be able to find a and b because the right-hand side is a polynomial of degree 1, but the left-hand side is also a polynomial of degree 1. So let's work it out. 2a minus 2ax minus b equals 2x plus 3. So let's write the left-hand side as an ordered polynomial, minus 2ax plus 2a minus b equals 2x plus 3. And now equate corresponding coefficients. You see that now this works because I do have an x term and I do have a constant term. So I will obtain the following system. The yellow ones, minus 2a equals 2. And from the green one, 2a minus b equals 3. So the first equation gives me a equals minus 1. And the second equation gives me b, 2a minus 3, so minus 5. And therefore my particular solution, yp of x, becomes ax squared, so minus x squared, plus bx minus 5x. And finally, as always, the general solution of the non-homogeneous equation is given by the sum between the general solution of the homogeneous and the particular solution. So it's y of x equals c1 plus c2 e to the x minus x squared minus 5x, where c1 and c2 are real numbers. Now, I just wanted to comment on when can you expect this to happen. Okay, so in general, we follow the regular rule that polynomial corresponds to a particular solution in the form of a polynomial of the same degree. But if that doesn't work, then you can multiply your particular solution by x. And you see, what was the problem before? We had a constant equals to a polynomial of degree 1, and that's because the derivatives here had killed the x. That's why if I multiply by x, now in my original particular solution, I've increased the power, and therefore it's not cancelled completely. Okay, y prime still has an x term, which ultimately is the one that gives us here the polynomial of degree 1. And as we will see better in the next example, the reason for this is because the right hand side here is a polynomial and lambda equals 0 is a solution of the homogeneous equation. So whenever this is the case, if you have lambda equals 0 being a solution of the homogeneous equation, if the right hand side is a polynomial, in the particular solution you will have to multiply by x.